So before we talk about solving quadratic equations, we must go over this huge idea known as the zero product property. And so basically what the zero product property states is, first we have a situation where we have two things. We have A and B. And A and B are standing right next to each other. A and B are being multiplied by each other. What the zero product property states, well, first of all, we can see the word zero. We know product means multiplication. When you have two things like A and B that multiply together and they make zero as a result, if you have this, well, then you can make a couple of logical conclusions. Imagine if A was 12. What would B have to be in order to have their product make 0? Well, if we have 12, we know 12 times 0 makes 0. So if A was any number that wasn't 0, then B would have to be 0, because any number times 0 makes 0. Similarly, if B was a number like 7, well, then what would A have to be? Well, A times 7 would have to make 0. Well, then A would have to be 0. Now this should make total sense, and I want you to know that this property by name, the zero product property. If you have two things that multiply together to make 0, then either the first thing equals 0 or the second thing equals 0 as a direct result by the zero product property. If you want, you could even abbreviate it, but you should know this from here on out. You should be able to say, oh, I understand, and know how to apply the zero product property. And you can even wow your Algebra 2 teachers with this. So here is our first situation where we can really directly apply the zero product property. And if you think about it, it's kind of like we have our A and our B multiplying together to make 0. So A is this factor 3x minus 1, and B is x plus 5. Together they are being multiplied together. They're standing right next to each other, so the operation is understood to be multiplication, and their product is 0. Well, to directly apply the zero product property, if two things multiply together to make 0, either the first expression could equal 0, or the second expression could equal 0. And so what's nice is this problem is it's written in factored form, meaning that we have reduced A and B kind of as far as they go. Perhaps this was a quadratic to begin, and then we were able to factor or break it down into a couple of linear factors. You see how they're both linear. They have, an x to the first power. They kind of look like y equals mx plus b type factors here. So they've been broken down. So now, since each part was already broken down, we can just kind of solve these out and find out what are the x values that when we plug in to the original equation written in black, what we plug in to get a result of 0. So we can really hone in on these x's. So let's do the right equation first. If x plus 5 equals 0, well, we want to isolate the variable, so we can subtract 5 from both sides. Then x is negative 5. So what that means is, that's our solution, x equals negative 5. That means if we were to plug into the original equation in black, everywhere there's an x, if we plugged in a negative 5, we would end up with a result of 0. Okay, so that's one of our solutions. Similarly, this left-hand side, we set it equal to 0. Now, you might want to divide by 3 first, but instead what we're going to do, that could get messy, we're going to isolate the variable first by adding 1 to both sides. Okay, so now we have 3x equals 1. So now x is being multiplied by 3. The inverse of multiplication is division. Divide both sides by 3. 3 divided by 3 is 1, so we figured out what x, or 1x, equals. 1x, or x equals 1/3. So these are the two solutions. What that means is if you plugged in x equals 1/3 in here, or x equals negative 5 here or here, the result would in fact equal 0. And you can check it, and we always recommend that you do in fact check it. You really must believe and understand this zero product property before we go further. So whenever you're trying to solve a quadratic or an expression with an x squared term in it, what you really want, or what your goal is to kind of have it look like this. Now this is known as like standard form of a quadratic equation. So notice how we have the quadratic term because there's an x squared, we have the linear term because there's just an x to the first, and then we have this constant term, meaning we just have some number. We always want to have the quadratic expression, this whole thing, to be on one side of the equal sign, preferably where the the coefficient, the number in front of the x squared, we want that a value to be positive. But we need this whole thing to be set equal to 0. That's always our first goal, so that we can apply the zero product property that we were just talking about. So we have to get it set equal to 0 first. So in this example, the least amount of energy it would take us to get this set equal to 0 is to move that 15 over by subtracting it. So now we have 0, and what's also desirable about this kind of shifting is we do in fact have everything collected on one side and the x squared term is positive. So this is very, very desirable. I would say right now we've kind of reached our goal up here. So now we have the quadratic set equal to 0. That's always like goal number 0, pun intended. From there, what we can do is we're going to try and break this up so that it's broken up into two factors, or an a times a b if you think about the earlier examples. So first things first, if we want to break this up into a couple of linear factors, because a linear times a linear is a quadratic, well, to get this x squared, the only way to make x squared is x times x. So we're starting to like unravel this riddle. Now, what else is there? Well, so we're looking now for numbers that add to -2 and multiply to -15. This is how we're going to kind of break this up. So what we always recommend is you really focus on the multiply first, and what you can do is you can list out all of the factors of 15. Notice how I'm ignoring the negative for a moment. The ways to make 15 with whole numbers are 3 and 5, or 15 and 1, or you could say 5 and 3 and 1 and 15. So those are the only ways to multiply to get to 15. So you can kind of list out the factors. We really recommend you even do this, scratch work on your paper. All right, so now you have to look at these pairings and say, well, which one of these multiplication options that makes 15, which one of these could ever turn out to yield a 2 as our leftover? Well, 15 and 1, you could make, if you added them, you could make like 16. If one of them was negative, you can make like 14. Those certainly aren't going to get us to 2. But right here is our winner. 3 and 5, those are 2 apart. So what we'll do is, let's say we placed a 5 here and a 3 here. Well, if you think about foiling or multiplying binomials, we know that we'll have like this, the inner and the outer terms are kind of connected if you were to distribute or multiply this out. So you just have to ask yourself now, to multiply to -15, one of these terms is going to be positive, one of them is going to be negative. Similarly, to add to this -2 right here, one of the terms is going to be positive, one of them is going to be negative. But to add to a negative, the negative needs to be on the bigger number. If we have -5 and we had +3, what that means is we'll have a positive 3x if we were to multiply this inner region here, this region right here. And if we were to multiply this outer region right here, we'd have a -5x. And just to verify, we know that 3 times -5 makes -15, which is what we wanted up here. We also know 3x minus 5x makes -2x. Similarly, we said x times x makes x squared. So we're just representing this quadratic in a different way. So from here, we can now apply the zero product property because we have factored our quadratic into 2 linear factors. And things won't always factor, but probably the examples that I'm teaching you how to factor on, they will factor. So now the zero product property says if we have a times b, here's our a factor, here's our b factor. If a times b makes 0, we can now set the first factor equal to 0. And similarly, we can set the second factor equal to 0. And we can solve for x, which is what the directions for a problem like this would say. Add 5 here, add 5 here. So here's our solutions. Now you might have to ask yourself, you always have to ask yourself when you're learning something, what does this mean? This means that if we took these two solutions, for instance, let's focus on one of them. If we took x equals 5, and we plugged in 5 here and we squared it, and we did negative 2 times 5 minus 15, that whole mess would equal 0, and you should check that. Similarly, if we plugged a negative 3 in here, we multiplied it by itself, subtracted negative 2 times negative 3, subtracted 15 from that mess, don't forget negative times negative is a positive a couple of times in there, you'll end up with 0. Similarly, you could take these solutions and you could plug them into the original, and this left-hand side would perfectly check and make 15 on this right-hand side. So you kind of think about what it means truly to be a solution. And now we have a wonderful example. What we notice that's different in this problem than any other problem is that the coefficient, or the number in front of x squared, is not equal to 1. In this case, it's 2. So step number 0, I'm just going to kind of move things around algebraically to kind of turn this into a quadratic expression that's set equal to 0. So we'll have the quadratic term first. Next will come this minus 7x, the linear term, and then last but not least is the constant term. Remember, you always want your quadratic term, and then your linear term, and then your constant term. And so if you had accidentally written this wrong, you could rearrange things. If you wrote 2x squared plus 3 minus 7x, you should rearrange things before you try and factor it. You'll always need to be in that standard form that I've been showing you earlier in the video. Okay, so now what's interesting is, we kind of proceed as we have in the past. But what's interesting is now to make 2x squared, the only way to do that is 2x and x, or x and 2x. That's the only option. What's nice is that we call that like the a value, that coefficient in front of the x squared. The a value is not equal to 1. So this is like the category of problem that we're dealing with here. In ax squared plus bx plus c equals 0. Now we're looking at that a term and it's not equal to 0. That's this type of problem. So we're just going to kind of proceed as we've been doing so far. We just have to break things up. Some students might accidentally put an x and an x here. That's not going to make 2x squared, so be wary of that. So now we're going to look for something that multiplies to 3. So we always focus on the multiplying region first. If you notice in every example, I've listed out the factors of that multiply portion. The only way to make 3 is with 3 and 1. That's great, because since 3 is prime, that's really our only option. So I guess we just have to figure out where we're going to put a 1 and where we're going to put a 3 in this mess here, so that we can factor our quadratic correctly. So you have to be mindful now. If you think about it, if you were to multiply the outer terms of this expression, you'll have a 2x here times whatever you place. You have a 2x here times whatever you place in this region. Similarly, if you think about the inner region, you'd have a 1x times whatever you place here. So now this 2 has like an extra pull. It's going to double whatever you place in this region. So I'm gonna actually, I think I should do it wrong. I think that's important to see things that are wrong. So let's say you're not sure where things go. You haven't been factoring that much. You put a 1 there and a 3 there. Well, if you think about this outer region, you'd have a 2x there, and on this inner region, you'd have a 3x. And you might say, well, is there any way that you can make negative 7x even if you mess with the signs on those via addition and subtraction? There's just no way. So that's not a great choice. So if at first you don't succeed, try again. So let's just try and get rid of our little errors here. That was bad and that was bad. Those two guesses weren't great. Well, now let's try again. I'm just going to kind of delete off everything that I tried here that didn't work. So 3 and 1, let's kind of switch the orientation. Let's put the 3 over here and the 1 over here. And now I can already tell that this is going to be great because I've got a 2x times 3. That's going to make 6x. On the outer, it's weird how my pen looks different. And on the inner, I'll have a 1x. And you say to yourself, can you make a negative 7x here? Well, yes, you could. If the outer term was negative, you'd have a negative 6x. 2x times negative 3 makes negative 6x. If the inner term was negative as well, you'd have negative 1 times x. That makes negative 1x. Now, what's nice is you're still covered here. To make 3, negative 1 times negative 3 makes a positive 3, because a negative times a negative is a positive. But a negative plus another negative makes an even more negative number of negative 7. So we did, in fact, perfectly factor this. Now, if you don't believe this, what you could do is you could just take a moment and just multiply this out, and you should end up with exactly what you have right here. If it isn't exactly correct, that means you messed up. Erase it, try again, be persistent. So now we've factored this, and then you've seen this a bunch of times. Now we can set each factor equal to 0, applying the zero product property. Okay. I'm really not sure what's up with my font here, but so I'll just solve out each of these. Now you gotta be careful. Maybe if I switch to black, it'll work a little better. Yeah, oh no, still messed up. What you need to be careful of is this region right here. Students think that once it's factored, they can say, oh, why? Well, the solutions are x equals 1 and x equals 3, because, we set them equal to 0 and the signs are going to change. No. There's a coefficient of 2 in the front here, so you'll need to divide by 2. Your solutions are x equals 1/2 and x equals 3. So be very, very careful to show all of this work and make sure you're factoring correctly. Take that time to take pride in your work. And here we have 2 problems for you. The examples in the video should give you the confidence and the ability to be successful on these. Remember, get everything set equal to 0. You're going to want to solve for x. Be careful if the coefficient of your quadratic term is not equal to 1. And make sure you show all your work, and don't give up. Kill some trees, work hard on these, really give it your best. Good job.